Now we're going to look at periodic functions. What is a periodic function? A periodic function is a function for which a specific horizontal phase shift p results in the original function. The smallest phase shift is called the period of the function. So if I just have this simply drawn function, a periodic function means that if you go a certain number of units, p, and you get exactly the same graph back that starts over again, then that's a periodic function. So if I look from here, this peak to this peak, I go here, I go down, back up, and I'm back at the peak again. So that p is the same. If I looked at where it crossed the x-axis, it crossed here, 1, 2, 3, 4 units, it crossed again. So that's a periodic function. Again, if I looked at this value, it shifted 1, 2, 3, 4, and then I start repeating again. Boom, 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 start repeating again. Okay? So that's an example of a periodic function. If there's a phase shift, if I can shift the graph to the right or left, p units, and I get exactly the same graph again, that's an example of a periodic function. There are lots of different types of periodic functions that you can see around you. If you're riding on a Ferris wheel and you look at your distance above the ground as you go around the Ferris wheel, if you just looked at your distance, not necessarily the angle, if you looked at your distance above the ground, then as you go around the Ferris wheel, your distance would be maybe start at 0 when you get on, and then as you go around the Ferris wheel, you get up to the top, then you go back down again, then you go back up again, then you go back down again. So it's a periodic function. At any time, any revolution, you're right back exactly where you started from. So the period of that would be the length of time it takes you to get back at your starting point. If you started here, it'd be the length of time it took you to get here. If you thought of a pendulum swinging back and forth, okay? At some given time, you're right back to where you started from. And then it goes through a cycle, and you're back at the same thing again. Through a cycle, and you're back at the same point again. We could think of it here. I go up, all the way back, and then here, and I'm back here again. So a pendulum would be an example of a periodic function. And I just draw a picture of the sun. The phases of the sun, as the time goes, the sunrise, as the year goes on, it gets later and later and later, then it gets earlier and earlier, and then, so it changes, but in 365 days later, you're right back to where you started from it. So a phase of the sun would be an example of a periodic function. We call these sinusoidal graphs. Graphs that they're periodic, we call them sinusoidal. I'm going to look at the sine function right now, and you look at two different variables. You look at the independent variable, and we're going to say the independent variable is the angle that the graph goes through. So as the angle increases, what does the sine value do? So as sine of theta, sine of 0 is 0. Sine of pi over 6 is 1/2. Sine of pi over 4 is square root of 2 over 2. And we keep going on the cycle like that. And then over here, it's going to become negative. So it'll be negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2. So then it starts to go down again. And if I plotted these points, now I just put some approximations on here. If 0 is 0, okay, pi over 6 is about 0.5. So if I go over 0.5 units and go up 0.5 units, that gives me that point. Pi over 4 is about 0.78. So if I go over 0.78 units, close to 0.8, and then I go up, square root of 2 over 2 is close to 0.7. So if I go up to 0.7 units, I can plot that point and continue on through this graph. Then this is what happens. I increase up to a point, the maximum, 1, and then I start to decrease back down to 0. Then as I said, this table goes on, I would continue going negative to negative 1, and then I would come back up to 0 again. So the sine of that, it would take 2 pi radians to get back to my original point again. So the domain is all real numbers. I can put any number in there. I've chosen these special angles, but I could put 1 radian in, 2 radians in, and find out the values. So the domain is all reals. The range is really important. The only range numbers I can get out are between negative 1 and 1. Those are the values that the graph goes between, negative 1 and 1. The period of the sine function, it takes 2 pi radians to get back to where I started from, so the period is 2 pi radians. The cosine graph is similar. Cosine of 0 is 1. Cosine of pi over 6 is square root of 3 over 2. So it starts at 1, goes down to 0 at pi over 2, goes to 0. And then, after that, it becomes more negative because in the second quadrant, the cosine of 2 pi over 3 is a negative 1/2, so it's below the x-axis, and it continues through there. So you can see that I plotted 0, 1, 0.5, 0.86, so that's there. And then if I plot all those points, and I make a smooth line because it is continuous, you can put, there's values in between there, makes a smooth line, crosses here at pi radians, crosses at pi over 2 radians, that's where it crosses here, and then goes all the way down to its negative. Then it'll cross here again at 3 pi over 2, and then it'll peak back, it'll make the peak up here again at 2 pi radians. So the cosine goes like this along the graph and finishes at 2 pi radians, or about 6.28 units. Again, cosine function, the domain is all reals. The range goes from -1 to 1, and the period of the cosine function is 2 pi. So it takes 2 pi radians to complete one cycle. So we'll study more of these and we'll explore more of these in class, but this is an example of periodic functions.